In this video, we're going to look at multiple regression. So here we're going to try to find the equation, a regression equation, where we have a response variable y, and instead of just having one predictor variable, we have two or more predictor variables. So when we are doing multiple regression, then the equation that we are looking for here, we're going to only be interested in linear regression here. Our equation looks like this. So we have b0 as the constant, and then we have some coefficient in front of the variable x1, a coefficient associated with x2, x3. How many? And so if we have n different predictor variables, we would have a coefficient in each of those n predictor variables. We can go through this in StatDisk. So here are those steps, which we will go through here in a moment. So you copy and paste the data into the columns, choose multiple regression under analysis. You'll need to identify the column containing the dependent response variable. You choose the columns prior to that are in the regression model. This choice should include both the response and predictor columns. So both the independent columns and the dependent columns. Important things that will be output here: an adjusted r-squared value. That gives you an idea of how good is the regression equation. How much is that going to actually predict? It will output the regression coefficients. And so b0 is the constant. b1 is the coefficient of the first column that you selected. So it's the coefficient of the variable associated with the first column that you selected. b2 is the second column you selected, and so on. So you might say, how do I choose the best multiple regression equation? Or you might say, I didn't even know there was more than one multiple regression equation. There is more than one multiple regression equation, because you could come up with, if you have n different variables, x1, x2, x3, let's say we have 4 different equations, or not equations, but 4 different variables, potential predictor variables. We could go through and say, we're going to use all 4 of them and see how that does. And maybe that's good, but maybe it's not. You might say, okay, we're just not going to use x4, or maybe we're not going to use x3, or maybe we're not going to use x2, or maybe we're not using x1. Each one of those would give you a different regression equation. And then you might say, maybe we're not using 1 and 3, or maybe we're not using 1 and 4, or just not using 1 and 2. Right? And so each one of those different choices is a different equation. So how do you choose the best one out of all of those? So the first thing is just use some common sense here. Right? So does it make sense for a particular predictor variable to have an impact on the response variable? Is it likely that there is a direct relationship there? So if I want to look at a particular item, I might say, oh, this predictor variable doesn't actually impact this response, or there doesn't look like it would have a natural impact, so it doesn't make much sense for me to include it. The amount of sales in ice cream doesn't look like it would have a direct impact on violent crime. So I wouldn't use ice cream sales to try to predict the amount of violent crime. Now, turns out those two things are correlated, and so maybe I would get a good guess based on that, but I might be able to find a better variable. Consider the p-value. So I skipped over that up there, but that's provided as well. So if the p-value is low, then that means it's good. So a low p-value says we would reject the null hypothesis that says that there is not a correlation. There's evidence of a correlation if that p-value is low. Other things that we want to look at is this adjusted r-squared. That adjusted r-squared, that's related to like our correlation coefficient. And so the higher that value, the better that we have. So we might want to only include a few variables. We want a small change in r-squared if additional variables are added. Right? So if we're up here and we have just these first three variables, and when we add in that fourth variable, if our r-squared only goes up in the fourth or fifth decimal place, then we're going to say, you know what, that's maybe not a real meaningful impact. And so even though it gets a little bit better, it's still not enough better, and it makes for an uglier equation. And so maybe we don't use it. We might say, I want to use 3 variables. And if we say we're going to use 3 variables, then you'll pick the 3 variables that give you the highest r-squared. Right? So we might choose x1, x2, and x3 from our example, imaginary example above. We might choose x1, x2, and x4, or x1, x3, and x4, or x2, x3, and x4. So we would roll through this regression, multiple regression, on all 4 of those options and see which one gave us the highest r-squared value. One other thing that we would want to consider when we're trying to roll through this is if we have 2 predictor variables that are already highly correlated, then we don't really need to include them both. They're going to give us kind of redundant information because they already are so correlated. If they're already highly correlated, then we're not gaining any new or much new information by including the second predictor variable. Perfect. All right, so those are our guidelines. So let's roll through an example. Find the multiple regression equation to predict family size using the data below. And so what I will end up doing in StatDisk, this is going to go into column 1. This will be column 2 and column 3. And so we are going to go through and we're going to try to predict family size, the size of a married couple's immediate family, based on the size of the wife's immediate family. And so this regression equation is going to look like B0 plus, I'm going to write this a little bit different so it more closely matches what we will see in StatDisk. Since this is column 1 and this is column 2, the coefficient for this column 2, they are going to call B2. So we'll have B2 x2 plus B3 x3. All right, so this is the x3 variable is the size of the wife's family. The x2 variable is the size of the wife's family. The x3 variable is the size of the husband's family. So let's roll over to StatDisk. I've already input these values, so they are in there in the order in which they were selected. Here we have the husband and wife. They had no kids, so it's just a family of 2. The wife came from a family of 3, and that husband came from a family of 4. And so we have all of those values here. So now I'm going to go up to analysis. And here we're doing regression, but now we're doing multiple regression. So I choose multiple regression. And we want to include the first 3 columns in this regression analysis. So we have those first 3 columns chosen, selected there. The dependent variable, the one that we are going to try to predict, that one that is going to be that response variable, that is in column 1. And so I will then evaluate this. And this goes through and it gives us our three coefficients that we are interested in here. Negative 2.25 is our B0. B2, so the effect that the wife's family size has is 1.00. And then B3, the effect that the coefficient for the husband's family size, we will go to 2 decimal places, so 0.52, 0.52. And so our regression equation, so y hat is negative 2.25 plus 1.00 times x2, where x2 is the wife's family size, plus 0.52 times x3, which is the husband's family size. And so if we wanted to try to, if we had a husband and wife where the husband came from a family of, let's say, 4, and the wife, let's say she came from a family of 5, then we could say, well, we will predict that the size of their family is going to be negative 2.25 plus 1.00 times 5, the wife's family size, plus 0.52 times 4, the husband's family size. And so if we roll through that, we get something like, I don't know, 4.87 or so. That's some quick calculations in my head. I think 2.08. Yeah, somewhere right around there. So that would be the predicted family size for this married couple. You can double check that math. Let me know if that's off a little bit, and we will take a look at it. That's it for multiple regression. We will talk to you guys later.